Alright, so in this problem, we have a man pushing a block, and the force he's exerting on the block is varying with time. So the question is, if we're given the mass of the block and the force at 5 seconds, how fast is this thing moving if it was initially at rest? So the first thing that I'm going to do here is I'm just going to write down the one relation for force that we all know, F is equal to ma. It's the first thing that pops in my head, so I'm just going to go ahead and write it down. So what I see here is I have force, which is unknown, I have mass, which is unknown, and I have acceleration, which is unknown. But the thing that I'm looking for in this problem is the velocity. So if I could somehow rewrite this in terms of velocity, then I could solve this problem. So the first thing that I think is that acceleration is the time derivative of velocity. So we can say that A is equal to dv dt. So this means that I can rewrite F is equal to ma as F is equal to m dv dt. Okay? So when I look at this, what pops into my head is that the force is a function of time. So that means it varies with time. And here we have dv dt. So I want to get rid of this dv dt and so that I can get an answer. So what I'm motivated to do is move this dt to the left side of the equation so that I can integrate over dt, and then I can integrate over dv on the right side and we can get an answer. So I'm going to just write out the numbers really quick and we'll see how that works. So this would be 2t plus 5 is equal to 10 dv dt. Alright, so the first thing I'll do is I'm going to multiply by this dt by dt. Okay, so if I rewrite this down here, this is 2t plus 5 dt equals 10 dv. So now I want to integrate over dt and integrate over dv. Alright, so I'll just write it right here. That's going to be over dt, and this is over dv. So now we have to ask ourselves, what are the bounds? And for dv, it's just going to be from 0 to v, because we're starting at rest, which is v is equal to 0, and then we're just going to our final velocity, which will be v. And here, we're looking for a time interval from 0 seconds to 5 seconds. So it'll be 0 to 5. So now all we have to do is do the integration and evaluate our boundaries. So if I integrate 2t plus 5, this will be t squared plus 5t. This will be from 0 to 5. And here we have 10 will just come outside, and then this will become v, right? Okay, so v, this is from 0 to v. So here, this becomes 5 squared plus 5 times 5 minus 0 plus, this is going to be 5 times 0. Okay, this is equal to 10 times, this will be v minus 0. So if we simplify this out, this is 25 plus 25, this is 0, so we have 50 is equal to 10, this is just going to be v, so 10v. So now all we want to do is we want to divide by 10. But first we should think about our units to make sure this will make sense. So force is usually in units of newtons, which is kilograms per meter second squared. So it'll look something like this. Okay, and mass is obviously in kilograms, so I'm going to put kilograms here. When we integrate over time here, we should drop one of the exponents from seconds out. It should be kilogram meter per second. And that's what we have here. This will be the units. So when we divide by kilograms, we should get meters per second. So that checks out. So all we have to do now is divide by 10. And this will give us v is equal to 5, so we'll be moving 5 meters per second to the right.